Yo, yo, yo! It's time for another SEAM at home. Yo, yo, yo! I'm Master P. It's my partner here, Gabie Lauron. Yeah. So, Gabie Ann, what are we supposed to do today?
We are recreating Newton's Cradle.
Newton's Cradle? What's that? It's basically this contraption. Can you see it? Alright, please verify. It's basically a cradle made from popsicle sticks, marbles, and nylon string. Marbles. So this is Newton's cradle, and these are Newton's balls. Alright, Gabie. Let's try to play with this thing. Science! Science, yo! Science!
Okay.
Mr. White would be proud. So, Gabie, let's have some questions. Here's a prediction. So what will happen if we lift one marble and let it go?
My prediction is the marble that the first marble. So since we after we release it, it will make all the other balls move.
Like this? Yo, yo, yo!
What's your prediction, partner?
The same. If I lift one marble, this marble will hit the other marbles, causing this one to go upwards. Let's try it out, yo! Science! Science, yo! Science! So, Gabie, please explain to us how this works.
Well, the first law of Newton would be displayed in this Newton's cradle. So the first law of motion would be the law of inertia.
Inertia? How does that work? Is inertia the law that says that when something is at rest, it will stay at rest unless and until another force causes it to move?
That is correct!
Whoa! Inertia. Science! What other laws are present with this model?
There is no other law present. On my acceleration.
Acceleration? How does that work?
So acceleration is present since if only one ball is released, then it only has a little force in it. So only one ball will move. So yeah, only one ball will move. But if two balls are released, then two balls should also move.
So, in other words, one ball here released will cause this last one to move. And if we pull back two balls here, or two marbles, the other two marbles here will move. I'll try to show it to you. I have two marbles in my hand, and I'll let them go. See that? Two marbles over at the other side moved. Science! Yo, 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 yo! Mr. Watt will be proud. A to the B to the Q. So, Gabie, let's ask some more questions for this. Science 8. S-T-E-A. S-T-E-A-M? At
Yeah.
home? Where did the A come from?
It's art.
Yo, yo, yo! Art is the bomb, yo! The bomb, the bomb, the bomb, yo! Alright. Some questions. Describe what happens to the cradle when you released one bead. Did the other beads move? Why or why not?
yes, the other beads move. And this is because, well, once again, the law of inertia. So, it is because of the first ball which interrupted the other balls which were at rest.
Alright, that's correct. When this bead or marble was lifted up, it had some energy in it. And when released, the energy from this marble traveled to the other marbles, causing this kinetic energy to transfer to the last one. Like this! Science, yo! Science! Yeah! So, which of the three laws of motion was demonstrated by the movement of the beads? Why do you think so?
So, as we said a while ago, the law of inertia is present in this Newton's cradle because the first bead would be the force which would interrupt the other bead at rest.
Alright. And that the last ball accelerated because of the energy of the first ball, right?
Yes.
Alright. Now, based on your observation, did the last ball reach the initial height at which you released the first ball? Let's see that again. This is about a finger in height. A finger. It's about more or less the same length of my finger. Only a bit less. It's a bit less because of friction. Where does friction come from? Well, first of all, from the marbles themselves. Because the surfaces of the marbles actually scratch against each other. That causes friction. Also the air. Friction is a type of force. And because of friction, it slows down the movement of said marbles. Right?
Yes.
Yo, yo, yo! So, real life application. How does creating a model of Newton's cradle help me have a better appreciation of physics and architecture? Yo!
Okay, so the architecture of an object or a model determines how it reacts or behaves in accordance with the laws of physics.
Then what?
So it really matters how precise or how sturdy your model is, and it will determine how the other things in your model react.
That sounds very interesting. Me, I'm going to use my imagination, and think of this like a suspension bridge. A bridge, you say? A bridge! A bridge! Let me explain. A suspension bridge is a bridge that is suspended by wires or cables. It's a suspension bridge. And the energy that travels through that bridge should be evenly distributed. Because should there be a great difference in the energy, the bridge might collapse. Cars will fall into the river. And people might die, dog. That ain't cool. That ain't cool. So, what have you learned today? G to the P to the L?
You've learned a lot, actually. So we've learned how very precise measurements in making models or these contraptions is very important, and it is actually very hard to make.
Very hard! Oh my god! Yes, it's very hard to make.
And there, how the precisement of the measurement is very important.
The precision.
Precision of the measurement is very important because it will really change the effect of the balls.
Alright, that's me, P to the L. This is Gabie, signing off, and have a Merry Christmas, everyone. Merry Christmas, internets.
And Happy New Year!
Toodles!